A sunrise is a statistical anomaly. It is not a right. It is not a constant. It is a temporary coincidence between a planet, an axis, and a star that has not yet discarded that planet into the void. Most worlds in this galaxy have never seen one. Most worlds never will. We inherited a story. Planets belong to stars, warm, orbiting, held. This story is a comfort borrowed from a universe that does not deal in comfort. It is a local condition, not a cosmic rule, and the data has run out of patience with our assumptions. The formation of a solar system is not construction, it is war. A collapsing nebula, a spinning disk of gas and dust billions of kilometers wide, governed by no central authority, only gravity, only velocity, only the cold arithmetic of mass and momentum. Planetesimals collide, accrete, shatter, reaccrete. The process is violent beyond analogy. There is no architect, there is only attrition. In the early life of a system, the inner worlds are bombarded continuously. Protoplanetary bodies slam into one another at velocities sufficient to vaporize iron. The oceans of a young Earth were likely boiled to steam multiple times by successive impacts before they were allowed to remain. This is formation. This is the cradle. It was not gentle. And at the outer edges, the gas giants form. These are the engines of ejection. Jupiter-class worlds accumulate mass rapidly, becoming gravitational dominance within their orbital lanes. They do not simply orbit, they interact, they pull. Their resonances ripple across the disk, warping the stable configurations of everything around them. A gas giant is not a passive body, it is a gravitational engine that can, under the right conditions, become a weapon. What we call a solar system is a brief interval of relative order following an extended period of chaos. And for a significant fraction of all planetary bodies that have ever formed in this galaxy, that interval ended violently. The planet was ejected. The star kept burning. The planet was never heard from again. This is not an edge case. This is the dominant outcome. The mechanism has a name: gravitational slingshot. It sounds almost elegant. It is not. When two massive bodies interact in a close gravitational encounter, they exchange energy, not in equal measure. One accelerates. The other, usually the smaller body, is flung outward at a velocity it did not previously possess. In controlled conditions, humans use this effect deliberately, slinging spacecraft around Jupiter to reach the outer planets without additional fuel. In the early chaos of a forming solar system, no one is controlling anything. Imagine a gas giant, newly formed, perhaps 3 times the mass of Jupiter, migrating inward. This is called orbital migration. It is common. As the gas giant moves through the protoplanetary disk, it disturbs everything in its path. It captures material. It hurls material. The orbital resonances it generates can propagate outward as gravitational waves through the disk, destabilizing planetary orbits that are not even in direct contact with the giant. Now place a fully formed terrestrial planet in the outer system, perhaps 1 billion years old. Perhaps it has an iron core, a silicate mantle, a water ocean 2 kilometers deep, a nitrogen-oxygen atmosphere thick enough to scatter light into colors across the sky. A stable orbit it has maintained without interruption for a geological age. The gas giant migrates, their gravitational fields interact. The terrestrial planet is caught in a sequence of orbital perturbations. Each pass brings it slightly closer to the critical threshold. Then, in a final encounter, lasting perhaps only a few decades of astronomical time, the geometry aligns. The terrestrial planet receives a gravitational impulse. The velocity transfer is sudden. The change in orbital energy is sufficient. The planet's orbital velocity, which was perhaps 30 kilometers per second, becomes 45, 50, 60. The escape velocity of the host star is no longer the ceiling. It is the floor the planet has just punched through. The planet is now on a hyperbolic trajectory. It is leaving. This acceleration is not gradual. It does not feel like acceleration in any meaningful physical sense for the planet itself. No dramatic rupture, no visible moment of departure. The planet simply moves. But now the mathematics of its motion are irreconcilable with returning. The binding energy is gone. The planet is free in the worst possible interpretation of that word. The entire ejection event, from the destabilizing resonance to the final escape vector, might span a few million years. In cosmic terms, this is instantaneous, a geological eye blink. One moment, the planet has a sun. The next, mathematically speaking, it does not. It has a receding light source, and then it has a fading point in a field of points. And then there is nothing. The planet does not stop. It will not stop. There is nothing in the interstellar medium to stop it. It will travel at tens of kilometers per second. It will be traveling at tens of kilometers per second in 5 billion years, in 10 billion years, in the final years of the universe itself, unless something with sufficient mass intervenes, which it almost certainly will not. The star does not disappear immediately. This is part of what makes the physics so cold. In the first centuries after ejection, the host star is still visible. It is the brightest object in the sky, now simply fixed rather than slow-moving. Gradually, over thousands of years, as the planet's velocity carries it into the interstellar void, the star dims. It passes through apparent magnitudes indistinguishable from the other stars. Eventually, it is gone into the background noise of the stellar population. There is no special moment of farewell. The star simply becomes one of many, and then it becomes one of the faint ones. And then it becomes invisible to any instrument standing on the surface of the planet. The thermal decay begins immediately. It begins during the ejection itself. A planet's surface temperature is governed almost entirely by the flux it receives from its host star. Remove the star, and the surface begins to radiate its stored heat into space without replenishment. The rate of this radiative cooling depends on atmospheric composition, surface albedo, and the thermal mass of the oceans and crust. But the direction is constant. There is only one direction. Within 1,000 years of ejection, a terrestrial planet's oceans begin to freeze at the surface. This is not gradual uniformly. Ice sheets form at the poles first, then spread equatorward. As ice covers more surface area, the planet's albedo increases, meaning it reflects more of the minimal residual stellar light it still receives. This accelerates the cooling in a feedback loop. The freezing becomes self-reinforcing. Within 10,000 years, the ocean is frozen solid at the surface. Within 100,000 years, the freezing front has penetrated kilometers into the water column. The pressure ice of the deep ocean, exotic crystalline forms stable only at extreme pressure and near zero temperature, propagates from the bottom. The ocean is not simply frozen. It is compressed into a laminated structure of ice phases stacked like geology. The atmosphere begins its collapse while the oceans still freeze. Carbon dioxide is the first major component to reach its dew point. It rains out as dry ice. Then methane. Then eventually, given sufficient thermal loss, nitrogen itself, the dominant component of an Earth-like atmosphere, reaches 77 Kelvin, its liquefaction point. It falls. Nitrogen rain covers the ice of the former oceans, and then itself freezes solid as the temperature continues to drop. The final atmospheric pressure approaches zero. Not zero because the gas escapes to space. Rogue planets retain enough gravity for that. But zero because every molecule of gas has condensed to a solid or liquid on the surface. The atmosphere has not been lost. It has become a coat of frost. The thermal surface temperature now stabilizes somewhere between 2 and 30 Kelvin, depending on the planet's distance from any background radiation sources. 2 Kelvin is the cosmic microwave background, the residual thermal noise of the Big Bang. This is the final floor.
The planet's surface temperature will approach this asymptotically and never undercut it. It will arrive at this temperature and remain there permanently. The darkness on the surface is absolute in a way that has no terrestrial equivalent. There is no moon reflecting starlight. Starlight itself, in the interstellar void, is so diffuse that it provides virtually zero illumination at the surface. If there were eyes on that surface, and there are not, they would detect nothing. The planet moves through a darkness so complete that it is not experienced as darkness. This is something else. This is the permanent condition. This is not a phase. This is the planet's identity for the remainder of the universe's active life. It is a frozen, airless, lightless body moving at tens of kilometers per second through the interstellar medium. It carries its former geology, its former ocean floors, its former atmospheric chemistry locked into its ice as evidence that something else once occurred. Forensic remnants, nothing more.
For most of the history of astronomy, rogue planets were a theoretical curiosity. The models predicted them, the ejection physics demanded them, but they are dark. They emit no light, they reflect no light. They were, functionally, invisible. The James Webb Space Telescope changed this. Not dramatically, not all at once, through accumulated gravitational microlensing data refined by Webb's infrared sensitivity and combined with statistical modeling, we arrived at numbers. The numbers are unacceptable. Rogue planets in the Milky Way galaxy do not number in the billions, they number in the trillions. Current best estimates, as of 2026 data compilations, place the population of free-floating planetary mass objects in the Milky Way at somewhere between 1 trillion and several trillion individual bodies. Some analyses push the upper bound higher. There are approximately 200 to 400 billion stars in the galaxy. If the rogue planet count is even conservatively 1 trillion, rogue planets outnumber stars by a ratio of at least 2 to 1. Some models suggest the ratio could be as high as 20 to 1. For every star you can see in the sky, there are potentially 20 dark worlds traveling between them, invisible, cold, moving in silence. The galaxy is not a collection of shining solar systems interconnected by empty space. The empty space is not empty. It is populated by a dense graveyard of frozen orphan worlds. The architecture of the Milky Way, as we now understand it, is not light surrounded by darkness. It is darkness filled with frozen bodies, punctuated occasionally by light. The shining solar systems are the exception. The rogue planets are the rule. This reframing is not rhetorical. It is a quantitative shift in how the structure of the galaxy must be understood. Planetary formation is extraordinarily efficient. Nearly every star forms planets. The ejection rate during those planetary systems' formative periods is high. The result, integrated over the 12 billion-year history of the galaxy's star formation activity, is a vast, cold, invisible population of free-floating worlds that have been accumulating since before the Sun was born. Some of these rogue planets are ancient, formed around the first-generation stars of the early universe, ejected during those systems' chaotic formation periods. They have been traveling through the interstellar medium for 10, 11, 12 billion years. They predate the Earth by billions of years. They will outlast the Sun by billions more. The census is not complete. It cannot be complete with current instruments. Every microlensing detection represents a single planet crossing in front of a single background star for a window of hours to days. We are sampling the population the way you would estimate the fish count in an ocean by dragging a single net through a single square kilometer. The actual population is likely larger than our current estimates, perhaps much larger. The galaxy is a graveyard. We have only just begun to read the headstones. Rogue planets do not announce themselves. This is the primary operational fact of their existence. A star announces itself. It emits photons across the electromagnetic spectrum. It is detectable from thousands of light years away by instruments tuned to almost any frequency. A rogue planet emits almost nothing. Its surface temperature is within a few degrees of absolute zero. Its thermal emission is a faint glow in the far infrared, indistinguishable from background noise at any meaningful distance. It reflects no starlight because there is no nearby star to reflect. It produces no radio emissions. It generates no magnetic field detectable at distance. To an optical telescope, a Jupiter-mass rogue planet 30 light-years from Earth is invisible, completely. Not difficult to detect, not dim, invisible. The only detection mechanism that works is gravitational microlensing. When a massive body passes directly between an observer and a distant background star, the gravity of the intervening mass bends the light from the background star. The apparent brightness of the background star increases in a characteristic curve, peaks, then decreases as the lensing body moves through alignment. This event lasts days to weeks. It is detectable, but it requires perfect alignment between observer, lens, and source star. And it tells you almost nothing about the lensing object's location, velocity, or trajectory. It tells you mass. It tells you it exists. It tells you it passed through this line of sight at this moment. A Jupiter-mass rogue planet 30 light-years from Earth could be traveling toward our solar system right now at 40 kilometers per second. It is dark. It reflects nothing. It emits nothing detectable. If it is not currently in perfect alignment with a cataloged background star, it is invisible to us. It will remain invisible until it is within the gravitational influence zone of the outer solar system. And at 40 kilometers per second, the time between entering that influence zone and arriving at the inner planets could be measured in thousands of years, far less if it is already closer. We have no dedicated survey instrument capable of detecting an approaching rogue planet except through microlensing. And microlensing requires alignment we cannot predict and cannot manufacture. We are dependent on chance geometry. This is not a remote speculative concern. The statistical density of rogue planets, if the trillion-body estimate is correct, implies that within a volume of space extending 1 light-year from the Sun in all directions, there are likely several rogue planets at any given time. The nearest rogue planet to Earth is probably closer than the nearest star. We do not know where it is. We have no instrument currently operating that can tell us. The bullet is already in the air. It has been in the air since before the Sun formed. We simply cannot see it.
There is a paradox buried in the thermal physics of rogue planets that the biology of extreme environments forces us to confront. Life does not require starlight. We established this on Earth. At the bottom of the Pacific, in hydrothermal vent communities, organisms exist in permanent darkness, under pressures that would crush a submarine, at temperatures that vary between near freezing and superheated. They do not use photosynthesis. They use chemosynthesis. They metabolize sulfur compounds, hydrogen, methane, compounds produced by the geothermal activity of Earth's interior. They are completely independent of the Sun. A rogue planet has a geothermal interior. The planetary core, if it formed from the accretion of radioactive isotopes, uranium, thorium, potassium-40, generates heat through radioactive decay. This is not stellar heat, it is nuclear heat, originating within the planet itself. On a sufficiently massive rogue planet, this internal heat generation can, over geological timescales, maintain liquid water at the interface between a rocky seafloor and the overlying ice. Not at the surface. The surface is at 2 Kelvin under meters of nitrogen frost. But kilometers down, beneath the pressure ice of the former ocean, there could be a liquid water layer. This is not speculation. This is the same mechanism that maintains liquid oceans beneath the ice shells of Europa and Enceladus, which receive virtually no geothermal input from Jupiter or Saturn directly, but are maintained by tidal flexing and their own internal radioactive decay. A rogue planet, larger than these moons with its own radioactive inventory, could maintain a subglacial ocean for billions of years after ejection. In that ocean, in permanent darkness, in conditions that have been stable for longer than the Earth has existed, life, if it began there before ejection, or if it began in the hydrothermal chemistry of post-ejection equilibrium, could persist, could metabolize, could evolve. It would be blind. Every organism in that ocean, across every generation, in every evolutionary lineage, would have no sensory apparatus tuned to electromagnetic radiation because no electromagnetic radiation penetrates the kilometers of ice above. It would evolve in total sensory darkness. Chemistry and pressure and fluid dynamics would be the entirety of its perceptual universe. It would have no conception of stars, no conception of heat from a distant source, no conception of sky. The ice ceiling above would be, to any organism that could conceptualize ceilings, the edge of existence. The universe to that biosphere would be the thermal vent, the chemical gradient, the slow convection currents of a trapped ocean. That is the totality of everything. We find this disturbing. We should not. We are the anomaly. We are the organism that happens to live on a surface near a star with a transparent atmosphere, with eyes tuned to the specific frequency band our star most strongly emits. This is not the modal condition for life in the universe if life exists elsewhere. The modal condition, if subglacial rogue planet oceans exist and support biology, is a blind organism in a sealed, dark ocean under miles of ice, with no access to the outside universe and no way of knowing it exists. That is the most common environment for life in the galaxy. If life exists at all outside Earth, it probably lives like this, sealed away, frozen over, unaware. Physical collision between a rogue planet and Earth is not required. The damage begins much earlier, at distances measured in astronomical units rather than kilometers. Consider the outer solar system as a gravitational architecture. Jupiter, Saturn, Uranus, and Neptune are not simply planets. They are the load-bearing elements of a dynamical structure that has maintained Earth's orbital stability for 4.5 billion years. The gravitational interactions between these giants, their orbital resonances, their Lagrange point configurations, these are not accidental features. They are the equilibrium state of a system that has settled into relative stability. Perturb one element, and you perturb the system. A Jupiter-mass rogue planet passing through the outer solar system at 30 kilometers per second on a trajectory that brings it within 2 to 3 astronomical units of Jupiter does not need to touch anything to cause catastrophe. Its gravitational field during the encounter, which might last decades, exerts measurable force on every body in the solar system. The perturbation to Jupiter's orbit is small but non-zero. The perturbation to Saturn's is compounded by Jupiter's altered trajectory. The cascade propagates inward. Earth's orbit is defined by an eccentricity, a measure of how elliptical rather than circular the orbit is. Currently, Earth's eccentricity is very low. We maintain a relatively stable distance from the Sun. A sufficient perturbation to the architecture of the outer solar system can increase Earth's eccentricity. It can also alter the inclination of Earth's orbit, changing the geometry of our relationship to the Sun's gravitational field. If Earth's eccentricity is sufficiently increased, the climate implications are severe. Higher eccentricity means greater variance in solar flux across the orbital year, more extreme seasons, potential destabilization of ice albedo feedback loops. This is the mild scenario. In more severe encounter geometries, the perturbation can achieve a different outcome. The gravitational cascade can place Earth in a resonance with another planetary body that amplifies over time rather than dampening. A resonance that adds kinetic energy to Earth's orbit with each cycle. Over thousands or millions of years, Earth spirals outward. Or it does not spiral outward. It is captured by the perturbation and spirals inward. Both outcomes are terminal. or Earth escapes entirely. The orbital perturbation, combined with a series of close approaches to other inner planets whose orbits have also been destabilized, provides sufficient velocity increment that Earth's binding energy to the Sun becomes negative. Earth is ejected. It becomes a rogue planet. This is not a uniquely human fate. This has happened to other worlds around other stars. We know this because those worlds are out there in the dark. Every rogue planet we detect is evidence of a prior solar system that failed to protect one of its members. Every rogue planet was once in orbit. Every rogue planet had a sun. And then the geometry changed, and the planet was released, and the sun kept burning, and the planet was not there anymore. There is no indication in the physics that we are exempt from this process. Our system has simply not yet been disturbed. The galaxy is old. It will continue to produce rogue planets. A rogue planet traveling through the interstellar medium that brings it into our system's gravitational influence could be deflected by the sun's gravity and pass through without incident. Or it could not. The probability of a catastrophic encounter in any given century is low, but the galaxy is 12 billion years old, and our sun has approximately 5 billion years of main sequence life remaining. The number of opportunities is not small. The question is not whether, the question is when and what configuration.
The final diagnosis is this: Earth is temporary. Not in the metaphorical sense in which all things are temporary, in the precise physical sense that the conditions which make Earth what it is are time-limited by stellar physics. The Sun is a main sequence star of intermediate mass. In approximately 5 billion years, it will exhaust the hydrogen fuel in its core. It will expand into a red giant, its outer envelope swelling to perhaps 150 times its current radius. The inner solar system will be engulfed. Earth may be consumed by the expanding photosphere, or it may survive just outside the engulfment boundary, its orbit having expanded slightly as the Sun loses mass. If Earth survives the red giant phase, it survives into the white dwarf phase, when the Sun has shed its outer layers and compressed its remaining mass into a body roughly the size of Earth, emitting a fading thermal glow that will diminish over billions of years. Earth's orbit around this white dwarf will be stable in the short term, but the gravitational dynamics of even a binary system are complex over long timescales. With the white dwarf's reduced mass, the outer planet's gravitational authority is recalibrated. The resonance structures that have held Earth in a stable orbit are dissolved. The slow dance of destabilization begins. Over time, Earth's orbit becomes chaotic. The formal mathematical term for this is Lyapunov instability. The orbit does not maintain predictability. Small perturbations amplify. The trajectory diverges from any calculated prediction, and eventually the orbital energy tips. Earth is either captured by another body, or it is ejected. It will be ejected. The statistics favor ejection. It is the dominant outcome. Earth will leave the cold remnant of the Sun behind. It will carry its frozen geology, its empty ocean floors, its atmospheric frost, its cities buried under nitrogen ice, its entire biological and geological history locked into its structure, and it will move into the interstellar medium at whatever velocity the ejection event conferred. It will travel in a fixed direction at a fixed speed indefinitely. It will cool further, not significantly further than it already will have cooled, because there is nothing further to lose. And it will join the census. One more frozen body in the dark, one more gravitational lens waiting to bend the light of a background star for a few days before passing on. One more number in a count that is already in the trillions and will continue to grow until the last stars exhaust their fuel and the galaxy goes dark entirely. And then it will not be one more frozen body in the dark. It will simply be one of the frozen bodies in the dark, because there will be nothing else. No stars to compare it to,
no warm exceptions to make it a rule. The galaxy will be a cold, dark population of stellar remnants and rogue planets moving through a space that is growing colder as the universe expands and the background radiation density decreases further toward zero. The protons themselves will eventually decay at timescales so vast they cannot be meaningfully expressed in human numerical terms. The iron cores of dead planets will quantum tunnel into more stable configurations over timescales of 10 to the power of 30 years or more. Black holes will evaporate through Hawking radiation. The matter that was Earth, that was ocean, that was the nitrogen sky over a Jurassic coastline will disentangle itself from its current configuration and disperse. There is no system, there is no architecture, there is no protected orbit. There is only the current temporary arrangement of matter and energy, which will not persist. The frozen Earth will drift. It will not arrive anywhere. Arrival requires a destination. The dark does not have destinations. It has only distances, and all distances in a universe with no light left to measure them by are the same.